Hi there, Doug Stewart with IT Creations, back again with some Intel Xeon 6 news. Intel has recently launched the Intel Xeon 6 Plus, codenamed Clearwater Forest. It offers magnitudes of performance upgrades from the plain old run-of-the-mill Intel Xeon 6 without the Plus. This upgrade only affects processors with efficiency cores or E-cores. I, for one, am glad that they've moved on from the Lake code names. Those were exhausting. If you like our channel, then hit that subscribe button. Notifications are optional. Let's take a look. What is the difference, you may be asking yourself? Intel Xeon 6 Plus family marks a significant evolution in server processors. It enables higher core counts with less power consumption. This results in greater server and rack density, helping to deliver more compute per square foot per kilowatt. All good for scale-out architecture, plus enabling more services on the same platform. If you are running servers with second-generation Intel Xeon scalable processors, you can realize some significant improvements, like a consolidation of 9-to-1. This update is engineered for power efficiency and core density with up to 2 times the core count compared to the Intel Xeon 6700E processors, a jump from 144 cores to 288 cores. Since these are available in 1 and 2 processor applications, you can get up to 576 cores with dual top-of-the-line processors. There are no Plus variants with P cores, at least not yet. The standard, or OG Intel Xeon 6, includes both P-core, codenamed Granite Rapids, and E-core, codenamed Sierra Forest CPU options, but the two cannot be mixed. The Intel Xeon 6 Plus is codenamed Clearwater Forest. It's built on Intel's advanced 18A process node, optimized for cloud-native 5G and high-density scale-out workloads. The previous generation were primarily manufactured using the Intel 3 process node for compute tiles. The 18A process node is a new manufacturing process. Intel Xeon 6 Plus is the first data center processing family to use it. The difference between the Intel 3 process node for Intel Xeon 6 without the Plus and the 18A processor node with the Plus is 1.2 nanometers. In other words, the non-Plus process uses a 3 nanometer class node compared to the 18A fabrication process, which uses a 1.8 nanometer class node. And as we all know, a nanometer is 1/billionth of a meter, or 10 to the negative 9th power. Of course we all know that. Does that make the physical parameters of the actual CPU smaller than that of the OG Intel Xeon 6 CPU? In short, no. Still the same size, but the Intel 18A process does shrink the individual transistors supported on the die, as in 3 nanometers compared to 1.8 nanometers. In case you're wondering how small that is, a single strand of human DNA is about 2 nanometers in diameter. A strand of hair, about 80,000 to 100,000 nanometers. Both share platform features like PCI 5.0, CXL support, and integrated accelerators. PCI 5.0 lanes are still at 96 with 64 CXL lanes, so no changes there. However, Xeon 6 Plus adds enhanced power telemetry for better data center management. As Intel's comparison is made against the 6700E series in the new Plus series product brief, there is a jump in memory channels from 8 to 12 with Intel Xeon 6 Plus. Also faster memory support at up to 8,000 megatransfers per second compared to the relatively modest 6,400 megatransfers per second. Both still use a DDR5 memory bus. I will mention these Plus CPUs still do not support MRDIMMs or multiplexed ranked DIMMs. MRDIMMs are still only supported with the OG Intel 6 CPUs with P-cores. Why, I am asking myself at this point, didn't they compare those to the standard 6900E Intel Xeon 6 CPUs? Seems to be this new Intel Xeon 6 Plus variant is more like the Intel Xeon 6900E than the 6700E version compared to in the product brief. That said, I am dealing with what Intel provided, and there are still some performance advantages with the 6 Plus variant. Although just for the sake of this argument, specific differences comparing the Intel Xeon 6900E and Intel Xeon Plus include a different code name from Sierra Forest to Clearwater Forest with Plus. Core types, who really cares about the name? The maximum core count is the same at up to 288 cores per socket. There is a different manufacturing process, Intel 3 versus Intel 18 on the Plus. The maximum L3 cache has also been upgraded from 216 megabytes to 576 megabytes with Plus, and support for faster DDR4 memory modules from 6,400 megatransfers per second to up to 8,000 megatransfers per second with Plus. Again, no MRDIMMs are supported on either of these CPUs because they are only compatible with those with P cores. Workloads are also somewhat different, with the 6900E targeted at custom cloud and hyperscale, whereas the Plus version is broad hyperscale and telecom deployments, as a general statement. And then there are the other options. What are the best case uses for each of these options? Intel Xeon 6 with P cores is for AI training inference hosts, HPC simulations, traditional enterprise databases, or workloads needing strong single-threaded performance. You may only get up to 128 cores, but you do get a large L3 cache of up to 504 megabytes, and access to that cache at exceptionally low latency. With the Plus version, you do get significantly more L3 cache at 576 megabytes. Choose Intel Xeon 6 with E cores or Xeon 6 Plus for cloud-native microservices, 5G core networks, high-density virtualization, web serving, and environments where maximizing cores per rack and minimizing the TCO to power consumption ratio is critical. The Xeon 6 family reflects Intel's strategy to address diverse data center needs with specialized cores rather than a one-size-fits-all approach. Standard Xeon 6 provides flexibility between raw performance with P cores and efficiency with E cores. Intel Xeon 6 Plus supercharges the efficiency track with Intel's latest manufacturing technology, higher density, and better power characteristics, positioning it as a powerhouse for modern cloud and network infrastructure. As data centers grapple with AI demands, power constraints, and scaling needs, this family of processors offers a number of tailored options. For the latest specs or benchmarks, check Intel's ARC database or independent reviews, as real-world results depend heavily on workload optimization. I do hope this information gives you a little food for thought on that next server purchase. If you have any questions, post them in the comment section below. If you need a little help determining the best options, then check out IT Creations and connect with one of our sales guys. I placed a few links in the section below for more information. Until next time, I'm Doug Stuman with IT Creations, and thanks for watching.